of go through some of these interview questions that I am asking a few of the top sauna manufacturers. So Bob, thanks for being with me today.
Thanks, Alex.
And I guess we'll roll right into it here. So maybe you can just start with how long you've been in the business and maybe quickly how you got started.
We got started, or I did, as a distributor. I used to own an organic little health food store and got into natural health when I was a young guy. And my doctor was a naturopath who believed in all kinds of, natural health kinds of modalities, including saunas. And this was way back. So I got into doing a cleanse every so often, including sauna detox. And then years later, I sold the business and was looking to do something else. And I thought, well, that little converted closet sauna was really tremendous for well-being and health and cleansing. So I looked around, for any manufacturer who had a small home sauna. I thought that would be a great product. Everybody could use it, the polluted world we all live in. So I looked around, and I happened to see a little ad somewhere where somebody said, come over and try this new kind of sauna, infrared sauna. Just came into the country. This was in the mid-'80s. I went and tried it, sweat like crazy, felt better afterwards. I said, I can sell these things, and I became a distributor. And then we bumped into a few chemically sensitive folks who didn't do so well with them, or they were concerned with the materials. So this was all kind of new to me, dealing with folks who were sensitive to even natural things if they were strong or aromatic or had volatile components, etc. So the objections basically were cedar for people who are chemically sensitive. They can react to it because of the volatile oils, what are called terpenes. And they're present pretty abundantly in cedar especially, but also in most softwoods. And softwoods are what saunas are typically made of. And back when I got in the business, there was nothing but softwood for saunas. So that was an issue that basically was a hurdle, our first hurdle, essentially, in trying to think of ways to improve upon the saunas. So the other objections were that the saunas were glued together. Plywood was concealed. Varnishes, as I best recall, were used, et cetera, et cetera. The windows were a form of plastic. So some of our chemically sensitive potential customers said, we'd love to detox, sounds great, the infrared sounds great, but, we really need to detox in a clean environment. It doesn't make any sense to go into an environment that isn't really pristine if you're going to heat it and, potentially outgas anything that's within the materials of the sauna itself. And we need to detox you. So we designed saunas around that. We tested wood species with sensitive folks and pioneered the use of white poplar back in the 80s. So we've been doing this for about 27 years selling infrared saunas, and about 26 years since we built our first one. We figured out how to build without adhesives and still have the unit be durable and strong, structural integrity. If you don't screw everything together with non-corrosive screws, countersink screws, use very thick wood, the option, and what most companies do, is to use thinner wood and glue the heck out of it. You basically have to coat the framing in very strong adhesives and then pin nail or use hydraulic presses to press the thin wood onto a glue-coated frame, and it really becomes a glue adhesive-based construction method, like most modern cabinetry is made the same way. What you see, the wood finish is like a veneer. It's glued on. By not doing that, we create a cleaner environment, but we also kind of inadvertently end up with a much more durable product because we're using non-corrosive steel screws and thick wood. So that's what got us going. We replaced the plastic windows with tempered glass, frame the wood with the same wood that we market it as. So when we say we use white poplar, we don't hide pine in it. There's several companies over the years have promoted saunas as hypoallergenic by promoting and describing the saunas by the visible wood and not telling you whether there's concealed plywood or what the framing material might be a totally different species, and often it could be an offensive species because typically pine or another resinous, cheaper wood is used for framing, although the sauna may be marketed as whatever the visible wood is. So that's an issue too. So anyway, we designed saunas, and another factor we wanted to incorporate into a really clean environment was, and a fault we found with the original saunas we sold, was that the air change wasn't very good. The typical infrared sauna may have a little inlet somewhere and maybe a little sliding hole in the ceiling to let air escape, but it's not a real strong rate of change. And what we found was after 5 to 10 minutes, the typical infrared sauna starts to feel a little bit stuffy. So we tried to remedy that. So we actually use each wall heater as a ventilator. So we channel fresh air all around you. Each wall heater is vented with fresh air coming in just below it, and then that air, as it rises along the heater, is channeled into the sauna's airspace, and then it's hot. It's rising right along the heating element. It tends to displace the stale air. It's coming in hot and rising. And we then carbon filter the outgoing air because you don't want that stale air, especially if you're really toxic and you're going through the initial stages of detox. You want to clean that outgoing air. So that was an important consideration for us to make sure that there's a nice passive constant air change in the unit. So that was our basic goal, was to make a clean, chemically safe, super effective sauna, and basically an ideal environment for detoxification. Kind of a long-winded answer, I guess.
Yeah, and you kind of went right into one of my questions here about wood types and that type of thing. So maybe we could just backtrack a little bit. But is there, so when it comes to, we try to educate our customers about basically what you had said, trying to really get more into getting knowledge about what goes into the construction. Right. And you mentioned a few things. Is there, because most of these companies are using thinner woods and using
right.
adhesives together, do you think it's possible to almost estimate if a company is doing that based off of the weight of a sauna? How heavy it is?
Well, it's an indicator. If you take a look at our, say, one-person sauna, we have a heavy crate. I think we ship it at 560 pounds. Out of the crate, it's probably about 420. The average typical personal size infrared sauna is, maybe 200 pounds at most. So if anything, it's an indicator, at least with our units, that we're doing something a little bit differently. And that's, the main thing with adhesives is that it's fast. You can coat cheaper wood with an adhesive and get a pneumatic pin nail gun and take thin wood and just shoot it on there or press it on there. So it's fast, and that's why companies do it, and the thinner wood is obviously cheaper than the thicker wood. So it's an economic thing.
Right. So I guess that's probably the only way, other than breaking open a sauna, being able to really figure out what a company is doing is.
Well, you can often tell with some companies' websites where they want to show you a layout and they maybe take a photo from above with the roof off. You can then see right along that perimeter edge, the top of the walls, and oftentimes you can tell by the discoloration. There may be a thin, darker edge along that perimeter of the wall tops. That's your paneling. It's usually virtually paper thin. It's a very thin, usually darker line around a whiter core, and that whiter core is going to be pine usually.
Right.
And then there's your cedar, your hemlock, whatever it is in a Chinese sauna. You can see that little edge of very thin wood. So that's a giveaway.
Yeah, it's a great insight.
Another giveaway is sometimes companies will show you a photo sequence of the assembly process, or they may have a video of assembly, and then you can see side edges sometimes. You can see the profile, and you can look for the same thing. You can see the white core and very thin, darker edges, and you can really get a good eye's view of just how thin that paneling is, and just how massive the gluing must be. There's no signs of fasteners. It's all glued together.
Wow.
With our units, conversely, you can look at our door, and if you look at the profile of our door, you see one thick slab of solid wood, and then at the top and the bottom, you see the heads of some countersunk screws going into other solid boards. If you look at most sauna doors, on the edge, you'll see a very thin trim strip. And what that is doing is covering the edges of the thin paneling that's been glued onto the core. So they want to hide that. So they then glue and pin nail on that trim strip to cover all that. So it's basically layers of thin glued together pieces of wood. So it's that's why I say, when I say it's adhesive-based construction, it literally is. And some companies kind of deny that. They're saying, we just use a little bit or a minimal amount. I don't think anybody really does. Either you do it the way we do it, or you glue the heck out of it. I don't think there's any middle ground. If you just use a drop or two of, baby glue, or, some companies tend to downplay this, but you wouldn't have a durable product. You've got tremendous heat stress in a sauna because of the rapid change in temperature. And you're using thin wood and you're changing that temperature dramatically up and then down again. It's going to really affect the wood unless it's thoroughly glued down with very strong adhesives or it's screwed down.
Right. Wow, great insights. That's amazing. So you can actually kind of figure that out, because I was wondering about that for a while, and how to guide my customers on maybe that is a concern for them. It's not just EMFs now that everybody's worried about. It's also more the off-gassing. But at the same time, then how do you tell? So there's at least a few tips. So that's really good information.
The average person doesn't know, and you certainly can't tell from looking at a photograph of a finished product, but there are those little telltale signs that you can look for.
All right, so let's talk about heaters. The probably the biggest other point of confusion with consumers, and why they really like our website is, we try to lay it out how it is about the whole ceramic carbon thing and really educate the consumer.
I appreciate where you guys are coming from on that too, by the way.
And most customers are totally confused by that. They hear all these companies are trying to say everybody's, our panels are the best, our emitters are the best, don't listen to these other guys. So so the question is this: what do you think is the kind of the most definitive, kind of foolproof way to assess which type of emitter, a carbon, a ceramic, or a combo, or whatever, has more fluency? Is there a way that a customer can actually get to the bottom of it, if you will?
Well, there's some laws of physics that pertain to that question. I should mention I've been writing a book for years as a consumer guide book, and I was just about finished with it 7 or 8 years ago when I had some optical issues. I had eye surgery and whatnot, and I couldn't work on the computer for a long duration, so it got put off. But at some point coming up pretty soon, I hope to publish a really definitive book as a consumer guidebook on understanding all these questions and the greater physics and the biophysics of infrared and how it affects the body and all that kind of stuff. So I can let you guys know when that's available. But to get to your question, there's several issues with this, and probably several are significant. Probably the key one in any infrared sauna, what's going to really matter is how much infrared is the body going to receive. That's kind of like a bottom line issue. All saunas have hot air and infrared energy. There's a convection radiation ratio, even in a traditional sauna. That's why the rocks are there. Besides that you can moisten them to create steam, they're also basically hardened minerals. They're igneous stones, which was once volcanic. It's molten heat-absorbent minerals that hardened and coalesced, formed rocks. They come from Finland. It's one of the greatest natural sources of zirconium on the planet. And the original patented heater in Japan for the first far-infrared saunas was based on zirconium, the zirconium oxide, and some other mineral oxides. They patented a formula to make the first FIR heaters, ceramic, just clay and heat-retentive minerals. The rocks are kind of like the same thing, only natural. If you don't mix clay and the minerals, they were just molten minerals and they hardened. So that's what's used historically in saunas to both allow humidification and to radiate naturally infrared energy. And it does it. It's not focalized like an infrared heater. It's not as close to you as an infrared heater, so its effects aren't as substantial, but it's still quite a bit of infrared energy in a traditional sauna. And the other factor is that with the interior surfaces of any sauna, once they get warm, they're going to become an infrared radiator. Essentially, wood is fairly emissive, meaning the efficiency with which a material can absorb and radiate thermal energy, far infrared. So in a traditional sauna, you've got rocks radiating a bunch of infrared kind of randomly all over the place, and the walls are putting out some infrared energy as well. It's not nearly as concentrated and focalized as in an infrared sauna, so the air temperature has to be hotter in order to get you to sweat. So there's a ratio. Low infrared, higher temperature. The same applies with an infrared sauna. The more infrared you can get to the bather's body, the lower the air temperature can be. So it's that same ratio like a seesaw. The ceramic heaters are stronger than the carbon heaters. So that historically, when they first made the first far infrared saunas, the temperature was typically 95 to maybe 115 as a starting level, maybe up to maybe 130, 140, somewhere in there. It's kind of gone up a little bit, I'd say 105 to 130s for ceramic heaters. You're going to sweat well typically because you're getting a lot of infrared on your body. The heaters are strong. And they're strategically positioned, so any heater that's near you, you're going to get all the energy from that particular heater. The thing with the carbon heaters is that the heaters are bigger, but the same current is going into the sauna. So the power, the electrical current, is spread out. what that does is dilute the watt density. In other words, the power per area of the heater is substantially reduced, and the strength of the heater is diluted. So you have weaker heaters. You have to use those saunas hotter. It's the same proportion. So in my mind, the ceramic is really the way these types of saunas should be built, and it's their essence, basically. It's the great benefit of them that you sweat well at a very low temperature. And once you weaken the infrared that much, as the carbon heaters do, you're back in the 140, 150, 155 range. It's kind of an in-betweener. So that's one issue. And, the size is somewhat of a factor, but still, when you're leaning on a back wall and there's carbon heaters, only what's right behind you is going to affect you. The infrared moves straight. So the whole back wall could be covered with, black carbon heaters, but only what's right behind you is going to have any therapeutic impact. With a ceramic heater, it's going to be smaller, but it's going to be rounded. It's going to have a reflector in back of it. And all of its energy is going to cover your whole back, too. So even though there's that size differential, the impact upon your body is going to be basically the same. And then the difference becomes how much infrared energy is that heater emitting versus the other one. Well, you can calculate that, and it's substantial. There's a rule in physics that you can compare emissions quantitatively if you know the surface temperature of two different heaters, and it's the difference to the fourth power. So that's huge. I mean, if a ceramic heater is 3 times, just throw it out there as a round number, and it's fairly close to that, hotter than a carbon heater, it's 3 to the fourth power. That's 81 times. 3 times 3 times 3 times 3. There's 81 times more infrared energy coming off of that ceramic heater. So they're dramatically more powerful. So your body's going to get more infrared energy. That's the critical thing. The other thing I don't like about carbon is that it's not really carbon. I look at a patent for one company who downplays ceramics, and I looked at a patent for their heater, and there was no carbon component to it. It was basically some ceramic coating layered on a piece of plastic or something with some cloth over it. There are other newer carbon heaters where there are a mix of thin ceramic and carbon fibers that are on some kind of a metallic foil that are imprinted into a layer of plastic, and then to get the low EMFs, they laminate, heat seal a top layer with the current coming in different directions, so you reduce the EMF that way. But what it is plastic. Plastic absorbs infrared, so it doesn't matter whether the fibers within the plastic or ceramic or carbon or who knows what. It could be anything virtually, because the plastic's going to absorb and become the emitter. But what companies who sell these kinds of heaters do, and the carbon fiber type heaters do, they'll then glue on some black synthetic cloth because they don't want to sell plastic heated saunas. You've taken photos of, sheets of plastic in cavities in the wall would look awful, so I assume that's why they do it. They take black cloth, usually. One company uses a gray cloth, but, most of them will adhere this synthetic cloth right onto the plastic. I mean, that's your heater. You look at a ceramic heater, it's clay and minerals. In our case, it's baked onto stainless steel for durability. With other ceramics, they're usually a solid ceramic. It's a natural material. With the carbon, carbon really has nothing to do with it. You're talking about a synthetic heater, plastic with synthetic cloth on it. The cloth is going to become the radiator. Once you cover a light source, if you will, it's going to either block or absorb that energy and may re-radiate it. With light, it won't do it so much if it's a black cloth, but with a thermal source like infrared, you're going to warm the cloth and it becomes your radiator. Just like plastic absorbed the original source of infrared within the layers of plastic, now the radiator becomes what's probably polyester. That has an emissivity somewhere in the 80s. It's still fairly emissive. It's still going to work. But when you promote a heater as being super emissive in the 90s or whatever, highly efficient, and then you're covering it, it's basically false information because the surface cover becomes your emitter. So anyway, I don't like the synthetic nature of them. Plastic heaters, glued on cloth, synthetic cloth, low emissivity, and the fact that they're weak. So to me, there's no comparison. I know the marketing is newer is better. Look, in this case, newer is not better. This is cheap Chinese technology, basically, that does not work that well. It's well hyped. It's well marketed. They probably sell a ton of saunas. And it is promoted as state-of-the-art, the newer stuff. It is newer. I had been told that it's basically on old waterbed heating technology where you get a current into sheets of plastic. But I like ceramic a lot better, mostly because it's much more effective and it's a more natural material.
Okay. Excellent information. And you do a couple interesting things I noticed nobody else does. And I think I understand it now a little bit more about some of the ways you lay out your sauna. So putting the rocks in there, the traditional, finished rocks with all their elements in it. Correct me if I'm wrong, but by putting the rocks in there, a combination of infrared emitters and rocks, you can basically effectively heat up more of the radiant temperature inside the sauna with the rocks. And if the temperature then inside the sauna is warmer, then you can basically set your ceramic heaters. They won't need to get as hot.
Right.
Because they're not essentially, the emitters are not what's then heating essentially the cabin.
Right.
We better
yeah, to be clear, we do build traditional saunas. We build all infrared saunas. We have near infrared as an option, and we have far infrared as an option in our traditional saunas. So we kind of run the gamut. I personally like a combination sauna where you have the ability to toss some water on the rocks and get it steamy if you want. You have a thermostat. For sauna marketing is somewhat based on distinguishing the infrared type of sauna from a traditional in kind of black and white ways by, the extremely hot versus the not hot at all kind of a thing. And really it's kind of in between there somewhere is the reality. A lot of public saunas are run too hot, but in a home unit, they're thermostatically controlled. You can warm it up to whatever you think is comfortable for you, and then you can go in and sit by the infrared and use it like an infrared sauna, but you still have the option to change humidity, etc. So I basically like that kind of sauna. They can still be just about as effective and, maybe stay in a few minutes longer and sweat a little bit more, and you probably equalize what goes on in an infrared sauna. There's some pros and cons to both, but yeah, you're right in your observation. You can just basically warm it up. The traditional heater is a very efficient airspace heater, whereas infrared's a relatively inefficient airspace heater. Infrared energy, as you probably know, doesn't heat the air at all. It heats you, but the infrared sauna still has to warm up to be effective, and it does that kind of in an incidental manner because the air around each heater gets hot because the heating element obviously has to get hot. So you get these little pockets of air being heated, and that summates to get your adequate warm-up time. So it's kind of a less efficient way to do it. So with a combo, you just crank it up to whatever you want pretty quickly, and then go in and use the infrared as you choose to.
So, do you think it's better to set, just in terms of detoxing, that kind of thing, do you think it's better to set the sauna, temperature really low and sit in there for longer? Or do you think you should just set it really, really high, go in for a crazy sweat for 10 minutes, or do 30 minutes at a really low temperature?
Yeah, I mean, it's a good question, and everybody's a little bit different. Some folks have to go through an acclimation process. So, it depends. If you're used to sauna bathing, some folks who are really chemically overloaded tend to not sweat well. They need to definitely start gradually. You never want to detox too abruptly, too fast. If you're not sweating well, you want to acclimate. Most people acclimate in about 3 weeks of relatively routine, regular heat stress. Just take a brief sauna every day or 5 or 6 times a week for 4 weeks, and most people will then be pretty well acclimated, and then they can kind of start pushing it a little bit and experiment. I think everybody's a little bit different. I think I've done it both ways. I'm kind of a sauna enthusiast, and I've used them for personal health issues over the years. And I've done it both ways, where you go in to a really extremely hot sauna where you can't stay in very long, and then go out and cool down a little bit, and then maybe go in, if it's a dual-tiered sauna, go in at a little lower, or stay in a little bit longer, come out, go in again. You'll eventually get your core temperature up where you'll kick in a good heavy sweat. I think with the far infrared, you want to kind of take advantage of the fact that it is really effective at lower temperatures, and so keep it pretty mild. With our units, I like to see folks in the 115 to 125 range, somewhere around there, which is pretty mild, acclimate, and then stay in. I think staying in longer is probably, in a modest, comfortable environment, is probably a better way to go to kick in that heavy sweat.
Okay. Just one last question here. So, everybody seems to have a lifetime warranty now. What do you think would be, if one of our customers were evaluating a warranty policy, what would be like a couple important things they might want to check on if they were
right. Well, the lifetime warranty, that's, when with all this influx of Chinese saunas, one of their selling points was, lifetime warranties. We used to have, I think, a 5-year warranty, and then we went to 7, and all these guys selling Chinese sauna are going lifetime. So, we kind of had to jump on board, and I don't really mind doing it because of the way we build our saunas. They're built like a rock. We've had them in clinics for 25 years, and they look like new. So I don't mind doing it, and our heaters are very durable too. So, but what in looking at some of the warranties that I've seen for other companies, they will often have all this fine print stuff where they're not covering any professional labor. If indeed you do need to hire somebody to switch out a part or make a repair of some kind, what they'll do is supply you with the part. They may not pay for the shipping of the part. They may not pay for the labor, etc. So what we do cover everything. It's a full. We have a lifetime warranty on the electrical, the heaters, and the construction, and we cover any professional labor that may ever be required, and the shipping of any parts that may need to be sent to the customer. We cover it all. So we do have a limited, I should say, 5 years on our electronic controls. Electronics are notoriously heat sensitive. They're not going to last forever in a hot environment. So we have 5 years on those, and we'll replace any part that you need thereafter at our cost direct from our supplier. So I think it's a really good warranty. But people have to read the fine print if they're concerned with that about the labor issues and shipping parts and all that other stuff.
Okay. Well, thanks for taking the time today. This was a lot of great, high-quality information that I think our customers will definitely benefit from. We'll have it right up there on the site. You can take a listen.
Thanks.
And, yeah, appreciate again the time. And it's Bob Morgan from Heavenly Heat.
Thanks, Alex.
All right.
We appreciate the opportunity.
My pleasure. We'll talk again. Okay.
All right.